Lesson for Lesson 7, Unit 2. We're comparing relationships with tables, and we're just going to explore how proportional relationships are different from other relationships, and we can actually change them ourselves, like this adjusting recipe problem. Lemonade recipe calls for juice of 5 lemons, 2 cups of water, and 2 tablespoons of honey. And we're going to invent 4 new versions of this recipe by following some of these restrictions that are given here in 1, 2, 3, and 4. So the first thing that it wants me to do is it wants me to make a recipe of this lemonade that would taste the same yet make more lemonade. Like I want it to serve more people. Well, if you want it to taste the same as the original, it's got to stay proportional. And the way to do that is to make a table, or just make sure that the ratio of lemons, cup, some water, and honey stay equivalent throughout all of it. So I'm going to make a little table here of lemons used, and then we've got cups of water, and then we also have tablespoons of honey. Now the original ratio was you had 5 lemons being used, 2 cups of water, and 2 tablespoons of honey. And we want to keep that 5 to 2 to 2 ratio. An easy way to increase everything yet keep it the same, I like to do, is just double every number. Right? If I doubled every number, 10, 4, 4, then I'm still going to have that same taste. It's just going to create more lemonade, because now instead of using 2 cups of water, I'm going to use 4. Now obviously that's not the only way to do this, but probably the easiest way to make it bigger. That's the way that I would do it anyway. So I'd use 10, 4, 4. Now if we wanted to make one that had the same taste, yet used less lemonade, then we would need to shrink all of these. And an easy way I think of doing that, to shrink all the lemonade usage, is to cut the original in half. Half of 5 is 2.5, half of 2 is 1, and half of 2 is 1. So we could use 2.5 lemons, a full cup of water, and a full tablespoon of honey. It would all taste the same, but make less. You wouldn't have to have as much. You'd only have a cup. So you need like an individual serving or something like that. The third one wants us to make another recipe, but we want the lemon to taste stronger. So this is going to put our proportion out of whack. So I'm going to do this one in a different color. So for number 3, we're going to create a different recipe for this lemonade, because it's not going to stay in this proportional sense here. We're going to use more lemons and less water or honey, and it's going to have more of a lemony taste to it. So I might do something like change the amount of lemons but not change the water. And if I want it to taste more lemony, maybe I do 6 lemons and 2 water and 2 honey. But it no longer fits our proportion. If I took all of these pairs here and divided them, I would not always get the same result. 6 divided by 2 is 3. 5 divided by 2 is not 3. So these are no longer all proportionally related. The green one that I've made is a different proportion, has a stronger taste of lemon. If I wanted to make the lemon weaker, if I wanted to make it weaker, then I could leave the water and the honey the same at 2 and decrease the amount of lemons used. So I could do like a 4-2-2 ratio. Still be lemonade, wouldn't have as much lemon to it, and it wouldn't match the other ratios that I had in the table. So sometimes relationships in these tables don't always have a proportional relationship. We have to be on the lookout for that. And that is Lesson 7, problem number 1, Unit 2.